Welcome to this video, guys. I'm going to be covering radians and degrees, what radians are, how they relate to degrees, and just doing some conversions. Okay, but before we get into that, I just want to mention something from the previous video that I may have forgot to mention. Okay, so I just want to look at, let's say, the point 360 and 0. Okay, so if we start, let's look at 270 rather. Okay, if we start at 270 and we take away 360 degrees, we get to here. Okay, and what we notice about this point, it's exactly the same value, -1. So we can say that sine 360 degrees minus theta is equal to sine theta. Okay, if we look at 270 again and we take away 180 degrees, we end up here. So we start at -1 and we got to 1. So we can say that sine 180 degrees minus theta is equal to minus sine theta. Okay, and we can get similar relationships with cos, tan, okay, by looking at the graph. But that's also something I forgot to mention. Okay, another thing is that some people pronounce sine as sin because it's obviously spelled like sin. But it's important to remember that sine is just an abbreviation for S-I-N-E. So it's pronounced sin, the same way that we have cos theta is just an abbreviation of cosine theta. Okay, it's not too important, but it's also good to pronounce things correctly. Okay, getting into the main video, radians versus degrees. Okay, so let's start off by drawing a circle. Okay, so I hope most people know that a circle contains 360 degrees. Okay, so some very smart mathematicians figure out that it's also equal to 2 pi radians. Okay, so I'm not going to go over the proof of that, but I'm just going to ask you to believe me. So what we can say is that 360 degrees is equal to 2 pi radians. Okay, and so we can simplify this a bit more by dividing by 2, and we can say that 180 degrees is equal to pi radians. Okay, so now let's get into some questions. So I want to convert from radians to, from radians to degrees. So how can I do this? So let's have 4 pi, and I want to get it to radians. So I have 4 pi, or I want to get it to degrees. So the easiest way to do this, or the way to make sure you don't make mistakes, is to just write out units and make sure they cancel. So I have 4 pi radians, and I want to get rid of the radians. So I have to have the degrees on top over pi radians equals, these radians cancel, and it gives us 45 degrees. Okay, so if we have 3 pi and I want to convert it from radians, I'm going to multiply it by 180 degrees over pi radians. Again, the radians cancel, and it gives us 60 degrees. Okay, so there's a bit of a pattern, right? So if you start with radians and you want to get to degrees, multiply it by 180 over pi. That gives us 30 degrees. Okay, so we can also use 360 over 2 pi, gives us the same answers, because we have, let's say, we have pi radians times 360 degrees over 2 pi radians. That cancels with that to give us 180, so we're actually left with this, which is a normal conversion, which gives us 180 degrees. Okay, the last one I'm going to do is pi over 2 radians, and we want to convert it to degrees, so we multiply it by 180 over pi, which gives us 90 degrees. Okay, so not too difficult. Essentially, if we have x radians, multiply that by 180 degrees over pi radians to give us y degrees. Okay, doing it the other way around, so we want to go from degrees to radians. Okay, so again we have, let's say, 140 degrees. I want to get rid of the degrees, so I have to have the degrees at the bottom, so 180 degrees over pi radians, and we're left with 7 over 9 pi. Okay, if we have 270 degrees, I want to get rid of the degrees, over pi times pi radians equals 3 over 2 pi. Okay, if we have 315 degrees times pi over 180 equals 7 over 4 pi. Okay, so what can we see? When we're converting from degrees to radians, we have the inverse of this. Okay, so the last one, 240 degrees converted to radians is equal to 4 over 3 pi. So we can say that if we have x degrees and we want to get it to radians, we multiply it by pi over 180 degrees to get it to y radians. Okay, so sometimes under test conditions, so we might forget how to do this. So how I remember it is, if we're given a number, let's say 45 and 45 degrees, and I want to convert it to radians, I think about what I want to change it to. So I want to change it to radians, so that pi has to be at the top. If I was going the other way, and I started with pi over 2, this is in radians, so I want to get it to degrees, so the degrees must be on top, and the radians must be at the bottom. Okay, and that's pi over 4, and that's 90 degrees. Okay, so that's pretty simple, guys. You just need to know this relationship, and then you're able to easily convert back and forth between radians and degrees. Okay, so there are certain advantages to using radians over degrees. I'll let you guys go Google that for yourself, but essentially in degrees like engineering, we only exclusively use radians and we don't really use degrees. Okay, but thanks for watching, guys. I hope this was useful.